How are you doing? Welcome to livestream number 161. Today's topic is troubleshooting in CAM. But I just gotta say something quick before we get into that. If there is a sync issue right now between audio and picture, just come back in a second. There's some issues on the YouTube end of things, and I will upload the recording of this if I have to. Alright, just had to say that. If everything is sync is good, everything is good, don't worry about it. If it's off, just come back in a second. Alright, today's topic is troubleshooting in CAM for Fusion 360. My name is Lars Christensen, and I really appreciate that you're taking the time to join these live streams. It is Friday, folks. That means it's all about CAM. But if you don't care about CAM inside of Fusion, then I'm sorry. Take the weekend off. If you are into it, then I hope that I get to show you. I hope I get to show you some good stuff here today. All right. With that, let's jump in and take a look at what we have here. What we have in Fusion today. So this is the part file we used last Friday. This is I kind of created this live stream last Friday about the Autodesk CAM challenge. You only have 3 or 4 days till it ends if you want to participate. So you can check that out if you want to win some pretty dang cool prizes. But I wanted to use this as an example on troubleshooting toolpath within Fusion 360, and this might be a little bit of an interesting one. We actually might just step a little bit outside CAM within Fusion 360 because troubleshooting in general can be a little bit of a struggle from time. I'm going to show you, give you my kind of tips and tricks to do that. So I hope that is useful if you ever need it. But most of the stuff I wanted to kind of cover is some of the things that I have come across in the past, and hopefully that is useful for you. If you have anything to add, the comment area, that would be a perfect place to do that. So I'm gonna start out of the gate here with what I think the most important thing when it comes to troubleshooting inside of CAM. Let's go ahead here, select the setup, and go ahead and post out the code. Now, I have done live streams about post in the past, and you definitely want to check those out if this is where you might run into some issues, because this can kind of be the tricky thing. But I just selected the standard Haas post here today because we're going to do a couple of things here. We're going to use this one. So I'm going to go ahead here and post out this code. You're going to see I get a fail notice here when I post this out. And some of you guys have maybe seen this, and this is almost maybe the most frustrating one, because you are at the end, you're ready to post out your code, and then you get this warning that tells you that, sorry, there's no code. One thing I wanted to point out about this is that they actually do place a warning area down in the end of the post. So whenever you get this thing coming up, don't just punch the screen or walk away. Check out what is in here, because that could be helpful. And in here we get a warning about work offset had not been specified using G54 as a work coordinate system, and that might give you somewhat of a hint on what is going on. And I will say this, that if you have ever received any empty toolpath or no passes to link kind of thing, most likely it's one or two areas. It's either your work offset, the way that is set up, or it could also be the boundary, what you have specified to machine. So that's not the magic solution, but that's definitely the two first places that I will start looking. So, how I have set up my work offset in the setup tab, and then What is the boundaries around my part? So with this, let's get out of this. And what you will actually see, the way I achieved this was, well, the way you want to go ahead and look at this is at the setup. So right click, go ahead and click at your setup. Make sure you have this gnomon set up the right place, and kind of like just work through the checklist, right? Be like, all right, that is set up the right way. How have you, what have you done with your work coordinate system call out? We've done live streams on this in the past too, if you need to learn more about that. The way I actually achieved this is if you click on the 2D adapter, this adaptive here, the second operation, you can see the tool comes down from the top. I flip this one, and if I right click and I go in and hit edit, you will actually see that I have tool orientation turned on. Tool orientation should really only be used if you have a fourth or a fifth axis on it. I can think of. I can't think of any other time you would ever use tool orientation. What tool orientation does is it lets you redefine the origin. So if I turn this off and hit OK, then you will see we'll regenerate and the toolpath would be right. Now another thing I'm going to do in this scenario instead is I'm going to right click on this and I'm going to suppress that operation. And I wanted to show you that as a trick too. If you have a lot of tool path created, it easily can become a little bit overwhelming, and right clicking on them and suppress them instead of deleting them sometimes can make it a little bit easier. Now I'm going to right click here and I'm going to generate tool path and let them all the other ones generate. So now you'll see there's a line through here what tells you that this is suppressed. So I right clicked and I suppressed. That's a good way to kind of like turn this tool path off without deleting it, kind of. Now you will see when I did that, you will see that I got a red dot next to it that tells me kind of like if this is the same thing you get for regenerate. It tells me that this toolpath is not processed right. But then you will also see that the toolpath right underneath it now suddenly have a yellow warning on it. These yellow warnings sometimes matters, but sometimes they're just they are what they are. They're a warning. If I right click on this operation and I can go down and say show log, and in this case here, it gives me, the developers are trying to give you some direction on what's going on. What is going on here is that when I created, and you can go back to Friday and look at Fridays when I created all these toolpaths, what happened here was that I used a derived operation. This second adaptive is a derived operation of the first. So now I've suppressed it, just giving me a warning that it can't reference that first one because it was a derived. So that's all that means. So in this case here, this warning doesn't really mean a lot other than just letting me know I suppressed the parent, I guess, of this one here. So be aware whenever you see these, you should definitely go in and check those out. So just a couple of things from this file. If you ever post something out and you get a warning, you don't get code, there's normally an explanation in there. And like I said, normally if you don't see any warnings in here, I would say go and look at your setup, right click at your setup and edit that and go in and make sure you have the things to find here. And the second one is your geometry, and we're going to come to that well, how about now? Let's get rid of this one. I kind of like created 4 different files. So that kind of takes us back to this place here. Now, what I wanted to try to do with this troubleshooting was when you go into troubleshoot inside of Fusion, let me just edit this operation for a second. There is only 5 tabs in here, and these 5 tabs always mean the same thing, no matter if you are in in 2D milling, 3D milling, 5-axis milling, or turning. They're all kind of doing the same thing. When it comes to troubleshoot through these, the easiest thing is actually just kind of like take a deep breath and go through these. So the first tab is always the tool. Of course, make sure that if you have any issues, make sure your feet and speeds are what they're supposed to be. That you didn't, by mistake, kind of change those, right? So make sure that those are good. Another thing that I've seen people do, if I go in and I highlight the setup and I say I want to simulate this, let's just go to tail, turn the stock on. Let's just do the first toolpath here. Notice how this toolpath, this is supposed to be a facing operation. Notice how that kind of cut in the middle of the stock. Now this didn't give me any warnings, but what I wanted to show you that I've seen some people do by mistake, and you can kind of see if I click on this facing operation. Let's go ahead and edit it. So like I said, the first tab is always your feet and speeds. Make sure those are good, you have the right tool selected. The second one is your geometry tab. This stock selection, I have seen people by mistake use that when they really didn't need to. So the stock selection lets you redefine the stock that Fusion should use to calculate the toolpath width. So in this case here, I selected this inner edge here, but normally for a facing operation, you actually don't need to select anything because then it will select the boundary that we set up in our toolpath. If I hit OK now, you will kind of see that now things looks more likely. That also goes if you go in and look at a contour toolpath. This in here looks a little bit different, but make sure, like I said before, that make sure you have the right geometry selected, and don't forget that you can click this little arrow. Make sure you are flipped on the right side of the geometry. But this stock contour also exists in other places in here, and it's a really neat thing. It lets you. It's great, just like this picture. And this is Mike Matara, who normally does these tooltips. If you had a stock that was not a rectangular shape, you could select the edges, and it will use that as the stock. But just make sure you haven't selected that by mistakes. So kind of two things in this geometry selection. Make sure that you have the right boundary selected. You are on the right side. You can hit that little arrow. And also make sure that the rest of them here are good. And again, tool orientation is only if you have fourth or fifth axis. Okay. Another troubleshooting thing here, if we go in and we right click on this operation, we see we had the warning here just like we had before. Go down and click show log. This one here is a little bit different. One of the ones you will see many times is the no passes to link and empty toolpath. That is really just processed later on in the troubleshooting code on the log and doesn't necessarily tell you too much. But here it says multiple depths are enabled, but the top is equal to the bottom. It is very easy inside of Fusion. I think this is probably one of the most I don't want to say most confusing menu, but the one that I know most people are troubling with. That's the heights tab in here. Done a live stream on the heights tab before in here. One good advice I can give you is that whenever you're working with the heights tab, start from the bottom and work your way up. Any other menu inside of Fusion, start from the top and work your way down. By the way, any other menu in any software, start from the top and work your way down. But with the heights tab, I like to start from the bottom, working my way up. Main reason is that the bottom height is normally where we want to be most focused, right? That's the depth of the cutter. In this case here, you will see that by accident, I did it on purpose, but in this case, it is set to stock top, meaning it's not machining anything, the top of the stock. Now, if I change this to model top, for example, and I hit OK, you will actually see that it would machine around that upper edge in here. So, you can for sure select the wrong thing, and the software will do what you what you tell it to, right? It's not, it's not gonna save you for every issue in there. But what I'm trying to do here is just give you some ideas about where to go in and kind of troubleshoot. So like I said, just for the people who just came in a little late, start out with your each tab. So make sure that your feeds and speeds are good. Make sure you have the right selection for what you want to machine. Make sure that these other ones are unchecked if they need to be unchecked. Whoops, I don't want to go out of it. In the heights tab, start from the bottom and kind of work your way up. And the reason also for that, besides that the bottom is normally the one we are most concerned about, is that these other ones are kind of like building on top of them, almost like Lego blocks. So you will see the top height of this part is the stock top, okay? But then if you look at the feed height, where it's going to start feeding your end mill from, that is the top height. That is this, plus 200, excuse me, plus 200 thousandths. So this is like a Lego piece. The top height, plus 200,000. Then the retract height is also stock top, plus 200,000. And then the clearance height is the retract height. So the Lego block from here, plus an additional 400,000. So the retract height is the stock top, plus 200, plus another 400. So this is why I like to start from the top and work my way. Okay. Enough of that. Let's get rid of this model. Same model, I just kind of like threw some different issues in here. The next one here, let's right click on this one and show log. This one is talking about lifting feed plane and lead in height. And this could actually refer me to that this has to do with the last tab, what is lead in, lead out, the linking tab. However, I'm not going to try to trick you here. The last file I have open, that is actually a lead in. Whoops, that is actually a lead in problem, and you will see that arrow message looks a little bit different. It actually talks about a collision. What this file here is referring to, show log, lift feed plane to topmost lead height. This is actually where the cutter cannot fit in the selected area in here. And another thing I wanted to show you, if you ever get these warnings, if I click this little bit in here, it will show down in here none, versus a toolpath that actually works, it will show you a kilobyte in here. So this is another indication that the toolpath is not there. There's nothing in there. Now in this case, so we did the feeds and speeds, we did the geometry, we did the height. Well, we are over on the passes tab. In this case, I've kind of hidden it down here. Look at the stock to leave that by mistake was added on here. So 1 inch, 25 millimeters, was added onto this little inside here. There's definitely no, with an 1/8 inch cutter, this is way out of proportion. If I turn the stock to leave off, then you will see the toolpath comes up and everything solves. My point about this is, again, when you go in and kind of try to troubleshoot this, one of the things that are actually pretty cool about Fusion, that the developers made me aware of a while back, is their main purpose with Fusion 360 Cam is no gouging. They will not, I should not say we, because I can't take any credit for this. The developers, they are writing code to make sure that end mill do not try to gouge your part. That's the main concern, besides making it easy to use. So when that end mill comes into that pocket, if it cannot go in there safely, it will say, nope, I'm not going in there. That's an important piece of information to know. So in this case here, when I'm turning on that I want stock to leave to be some ridiculous amount, 1 inch, so 25 millimeters, whatever you want to call it, that cutter is not going to be able to go in there right now, and Fusion is saying, no way, I'm way too close to gouge the part. I'm not gonna go in there. So when you're troubleshooting, like I said in the beginning, your work offset, but then like, can this cutter actually, can it actually make it in there without gouging the part? Whoops. The other thing I wanted to talk just for a second about before looking at the last example, now we are in the passes tab, and that is something that I think causes a little bit confusion also, and that is this one here, compensation type. And I don't blame anybody at all, especially if you're fairly new to CAM, if this is a little bit confusing. So I'm gonna try my best in 5 minutes or less to explain to you what this does. Now there is a good explanation that comes up on the screen here. In computer, in control, where, and inverse where. This is what we're gonna do about this. We are going to open a new file, brand new file. I'm gonna show you something maybe you didn't know. I'm gonna start a new sketch, and I'm gonna hit my S key, get my center rectangle, and I'm gonna draw up a square that is 50 by 50 millimeters. That's hopefully everybody can follow me this far. I'm also gonna go ahead here and draw a circle, and I'm gonna make that one 10 millimeters in diameter. And then I'm actually going to make it vertical to here, and I'm going to make it tangent to here. So my question to you is, did you know that I'm gonna go in here, right click, show dimension. So now we can see the dimensions here, 50 by 50. Did you know that you can actually drive CAM geometry from a sketch? Go into CAM, let's do a setup. Make sure my coordinate system is right here, that is going up here. Just like this here, it doesn't really matter about the stock for right now. If I go in here and do a contour, 2D contour, I'm gonna select this edge right here. Make sure we are on the right side, right? And let's go in and select a 10 millimeter end mill, because that was kind of what I drew up there. 10 millimeter flat end mill. Okay, let's hit OK. So we just drew, let's gonna start over here, doesn't really matter. We just drew, this rectangle. We're driving this rectangle going around here. Now here is where the important thing comes in. If we go over to the compensation over here, right now it's set to in computer. And that means that the computer, the code in here is going to do all the calculations compensating for that cutter. So when it creates this output, it will take whatever cutter you have specified in here into consideration. So if I go ahead here and I post this code out, and this is again why I just use that standard Haas post, you will see that as it's going down here, so we kind of know that the cutter is the cutter is 10 millimeters and the box is 50, so it's 25 by 25. You will actually see that when this one comes in, it's gonna move over in X31 to do the lead in. Well, I should probably start from the beginning. It's gonna come down to C0 because we're just driving the sketch. It's gonna turn the lead in, lead out on, and it's gonna walk into the part. And here you will see the 30. The 30 here is that move into the part. Another way you can look at this, if you want to, if you right click on your operation and you go and click View Toolpath, you will actually see your X and your Y coordinates in here, and you can see these coordinates. Now, right now, when we are in the computer, the code that will be output is literally as it knows what the cutter is, and it will just program with that one. In control, it's a little bit different. The tool will not be calculated here, but instead it will insert what is called a G41, G42 code that will allow you out of the machine to specify the diameter of the cutter. So if I click on in control, and so now I switch to in control, I hit OK, and I post this out. Well, actually, let's just do the view toolpath, same thing. Now you will see that the G45 is turned on here, and you will now see that it's going in and taking the 25 by 25 on. So now you will have to, out at the machine, you will have to put in that you have a 10 millimeter cutter, or it will not compensate for that. The last one in here is the one that is called wear. And wear will do the same thing as the first one did in computer. It will calculate half of the cutter, but then it will still add a G41 and a G42, and that will allow you to add a little bit of wear if the cutter should wear. This is what I have always normally used. I think actually in computer is normally for very older controllers, like older machines that didn't have compensation to add wear on your cutter. In control is used many times if you have a probe on your machine that measures the tool for you, because that will put that in your controller. Wear will then add, do the same thing as in computer. It will add whatever size end mill you have input, but then it will still give you the G41, G42. So if there is any wear on the cutter, and inverse wear is just doing the opposite of wear and off. But I think I can I'm gonna try to see if I can do a better job showing you this than what I'm just doing here, because it is Friday. We have a new addition to the live stream. Now this, let me see if I can do this. This might throw off the sound a little bit, but check this out. Let me flip back again. I actually now have a camera on that controller running. Woo! Okay, so my audio is probably gonna go off because now I'm walking away. But now I'm over at the controller here. How you doing? So this is just me trying to do this, and maybe this is not great. Actually, what I had to do yesterday was I put film on this screen. I have like a tint on the screen here, because if it's on like this, it's too bright to see. But hopefully you can somewhat see it. All right, I have a program running right now. Let me just stop that. So not only what happens, and this goes for pretty much any machines that I've ever touched, and maybe this is not focusing on it. But if you go into your offset page on the controller, you will normally have length. And length is of course the length of the tool, but then over in the other section, you will have something called diameter. And the diameter section, the first one is called, on the Haas controller, is called geometry, but I mean, it's also done that on other controllers. The geometry is the full diameter. So if you're using in control, you will input the full diameter of your cutter. So in this case, the 10 millimeters. And if you have a probe on your machine, it will many times, where it's measuring the diameter of the cutter, it will input that automatically there. The next line is wear, and this is where you can insert the diameter of the cutter if it wears down. And normally a standard end mill in United States, at least, I should only talk for United States, is plus nothing minus 3. So it can actually be 3 thousandths small. And that means that you might have to go into that page that you just saw in there, and you might have to go in and kind of correcting that in there to be able to kind of tweak that setting. So I hope that was an exciting segment. I hope the sound was not too bad either. I will read the comments later. So that is what this does in here. Now, with all this, I will say make sure that you maybe read up on your manual on whatever controller you have on your machine. But in general, I will say in computers for older machines that didn't have the compensation, in controller wear is probably one of these two different places you want to look at. Okay, let's look at the last. I hope that made sense. Let's look at the last file here. So the last one I did was, again, I showed you before. We right click and show log. This one here is actually a lead-in issue, and it will show you here console was not machined because the given lead parameter would cause a collision. Again, like I said, the development team, that is one of the ways they're writing the code, is to prevent that from happening, that it will not gouge. So many times these issues are operator error, right? If I place this in, you will see again we get the tool path back right here. So that was somewhat what I had planned to to show this Friday. I hope that kind of gives you an indication. Another thing helps you troubleshooting your toolpath. Another thing I just wanted to kind of maybe break down for you here at the end. There's kind of, and this is just my experience, there's kind of 3 different ways that I look at how to troubleshoot things in CAM when in the real world when it comes to figure things out. There's 3 different aspects. There's the CAM Fusion in this case. There's the G code, and then there is the machine itself. And I have always, my first approach is always go back into the CAM, go through the 5 tabs, and just, I know I maybe will not find the issue, but at least just double checking that I didn't, fat finger something in and got a wrong thing in there. The next thing is to actually post out your code, because the code will never lie. Code is code. So if you post out the code, you can actually go in there and you can try to kind of figuring out where's the machine going. The numbers should add up, like we just saw when we looked at the code before. I drew, and maybe the best thing is to draw up a rectangle and put toolpath around that one, and make sure that, yep, I got the 25 plus half of the cutter, so 30 is output there. Because if the code is right, then you know that the last place is the machine. Then something maybe you didn't pick up right on the machine. But if the code is wrong, then most likely you got to go back into your CAM. Code will not lie. So that's kind of like my approach to it. Of course, you got to also have a post processor that is good, and you can go to cam.autodesk.com, cam.autodesk.com/posts, and you can get the different posts that is available in there. I should have put that in a link in this video. Friends, it's Friday. I hope you have a good weekend planned ahead of you, and you have some fun stuff to do. I will be back Monday. We will do a live stream on Mondays. We should be back on normal schedule. That's it, folks. If you're watching the recording, thank you so much for taking the time to watch these live streams. Really appreciate it. Thumbs up if this is good. Thumbs down if it's not. Be honest. And again, if you haven't subscribed to the channel, it would really mean the world to me. If you would do that, that is kind of like how I can tell my boss, yay, look at that. People are actually not only watching, but also kind of committed to watch more of the stuff. If you're in the live stream chat, I'll be in there in a second and say hi to everybody. So, hope you have an awesome weekend, and I will see you again Monday. Take care, folks.